Hey guys, I wanted to go over something with you. Um, this is going to be very specific for people with Gen 3 ECU using content sensor. And what it's about basically is dialing in your VE table using equivalence ratio, which is basically tuning in lambda. Now, there's reasons why you would want to do that. Mainly because the other method of doing it is with AFR error, which I have a histogram set up for. And basically what that does, excuse me, is it tells you the difference between your commanded air fuel ratio and what you're actually getting at your air fuel ratio gauge. Now the problem lies when you're running ethanol is it's reporting in AFR, which, for example, if I scroll this here, see here's the air fuel ratio commanded is 10.5. And you'd say, wait, that's way too rich. But what you got to remember is this is ethanol. This is 66% ethanol. So what'll happen is it'll report an error, a huge error, because it's calling for a 1.0 lambda, which what's nice about lambda is it's always 1. So lambda for gasoline is 14.7, which is what it's commanding. But be it that we're at 10.5, it's because we have a huge percentage of ethanol in here. So there's a few tables that correlate to this. So what happens if you try to do this with AFR error, it's going to report a huge error. It's going to say you're 30% off or whatever. And that's just because it's commanding a 10.5 because of the ethanol content, when in reality it should be 14.7. But it gets skewed because you're using ethanol. So there's a few tables that correlate to this. This first table here is your Stoich AFR, and this basically is for the content sensor. If you're at 0% ethanol, your AFR Stoich is 14.7, 14.68. If you're at 100% ethanol, you want an 8.5. I'm at like 66, so I'm in between right here. That's why we're seeing a commanded of 10.5. So what you can do is set it up so you are using lambda, and that will always be correct. See, now this happens even if you're doing the AFR error with regular gasoline. There's still a percentage of ethanol in regular gasoline. It's up to 10%. So it's going to skew those AFR numbers as well. So this is a better method of dialing in your VE table. So now for idle, you want a 1.0, which at this ethanol content is a 10.5. And with gasoline, if it was 100% gasoline, it would be 14.7. But again, it's not because of the ethanol content. So what you have to do is you get your air fuel ratio gauge hooked up to the HP tuners. I have it wired in down here. And the thing that's nice about all air fuel ratio gauges is that they read in lambda, and then they just do the math for you and then display it in gasoline scale. So that's how they work, and it works fine. But again, so let me go back to these tables here, because you want a 14.7 on the gasoline scale. I'm just going to speak in the gasoline scale because it's easier for people to understand. But what you want for idle is not necessarily what you want for example, this is power enrichment. Like when you step on the gas, this is a multiplier or a divider or whatever. So wherever you're at here, if you're at 0% alcohol, you want a 14.7 when you're cruising and idling. And if you divide it by this number, this will be power enrichment. So when you step on the gas, to accelerate or whatever, you don't want 14.7. You want like a 12.5, 12.7, something like that. So that when you divide that, that's what it's going to give you. So that's what these numbers are for. So if you would take 14.7 divided by 1.15, it would give you roughly, I think 12.7 or something. So that's what it's going to command, what kind of air-fuel ratio you want when you step on the gas slightly. And then there's this other table down here, and this is your boost enrichment. Once you get into 105 kPa, okay, then it's going to go into boost enrichment. And same principle here. You take your let's use gasoline for an example, 14.7, divided by this number here. When you're at 200 kPa, 1.3 I believe is 11.5 or 11.3, 11.8, somewhere around there. I'm not good at math, but so that's what determines your commanded AFR over here. Where is it? Up here. Let me scroll down. Why is this not working? Oh, there we go. Yeah, here we go. 1.0. So if I went for a drive, and I got this chart set up, this graph set up, which you have to make sure this stuff matches your VE table. For example, the RPMs across the top here, and these are the columns, and then the rows is the manifold absolute pressure. And there's videos on how to do that, but essentially what you do is you go to the VE table, you copy the labels, and you paste them in and make a new graph and call it EQ error. The other thing you have to do is get your, see, here's my air fuel ratio gauge. You have to transform this. You just right click on it, you hit transform, and then you would go to equivalence ratio, and that's how you would get it to read in lambda, basically. So that's all set up. Now I went for a drive and I was reading, and so let's take a plot point here. For example, 160 kPa. I'm 7% rich. So if you take that number and put it in your VE table, it's going to pull out 7% fuel. So that's what it does. It's reporting an error. It reports what you are commanding, which is over here, and what you're actually getting. So now if I hit play, it'll show this is me driving, and you'll see this number change as you, for instance, if you step on the throttle, see, these numbers are where it was lean. So I'm really interested in these kind of numbers here, and this down here is when I'm into boost and it's real rich. These numbers up here this is like transient stuff when you let off the throttle. It's a stick car, so, and it's 30 kPa. My engine idles at 50. So a lot of this stuff doesn't even matter really. I mean, you can tune that, but it's not going to affect much. It's just you're rarely at 30 kPa. I actually like it a little rich there, because that you kind of get into that when you're pulling out, letting the clutch out, and the engine dies a little bit, and then it fattens it up a little bit. But yeah, see, this is as we go along here, it's playing, and yeah, this is just me driving around normal. Let me see if I can get over. I want to see if I can get to the area where I got into boost a little bit. This is just me driving around. Let me pause this, see if I can scroll it over. And I'm just going to watch the throttle position, see where I laid into it a little bit. Right there. So if we play it from here, see, look, already, you see the air fuel ratio commanded was 8.9, and that's on the ethanol scale. And now if you were to do with the AFR error, it'd say, whoa, you're way too rich. And then if you try to tune with that, it's going to fuck up your VE table all over the place. But see, the thing that's interesting about lambda is 0.85 lambda is the same for any fuel. So that's why it's nice to use lambda when you're doing this sort of thing. Okay, yeah, here's a little spot where I get into it a little bit. Look at throttle position, 20%. And you see it up here. I'm hitting 120 kPa. Just getting into boost a little bit, and you'll see that the commanded air fuel ratio changes. And that's what's nice about this, is it's going to report your error, how far off you are on what you want, what the computer's commanding, and what you're actually getting. So what you do then is you would take this table. Let me pause this quick. Take this table, you highlight the whole thing, and then you go back over to your main VE table, airflow, primary VE, and then you highlight this whole thing, and then you right click, and then you would paste special. Why is it not letting me do it? Hold on, did I not right click, copy, right click, paste special, multiply by %half and creep up on it. And there we go. And then you would write this. And then you go for another ride and do it all over again. I know that was a little convoluted and complicated, but hopefully you guys were able to follow. If there's any questions or whatever, just let me know in the comments. I'll talk to you later.